We're about to begin, so just getting your attention. Welcome, everyone. My name is Curtis Busby Earl, and I am here in the Department of Computing within the Faculty of Science and Technology. And I'd like to extend a very warm welcome to you all. But we have some formalities that we must still adhere to. And so let me begin by extending an exceptionally warm welcome to our Pro-Vice Chancellor and Principal, Professor Dale Weber. Good afternoon, sir. I'd also like to extend our welcome to our Dean, Professor Michael Taylor. We have a number of specially invited guests who I am seeing at least a couple of. First, I'd like to extend that welcome to Professor David Tennant. Good afternoon, sir. I believe the Deputy Dean for the Faculty of Humanities and Education is supposed to be here, Dr. Therese. Yes, Ferguson. Just making sure the mask. I had to welcome. The HODs and other colleagues in the FST, good afternoon and welcome to you all. There are some other very specially invited guests who are here today. Prof. Stephenson has managed to bring out some big guns, so to speak. First of them, the Honorable Emeritus Professor Anthony Chen. Good afternoon. I know we have never met, but your name on your reputation precedes you, sir. We also have one Mrs. Pauline Stephenson, who is Professor Stephenson's mummy. Good afternoon. We are very happy that you could both join us this afternoon. All of the other specially invited guests. Now, if I have not mentioned anyone, please, that is my fault. I'm not aware of those who may have agreed to come and join us, but I am very happy that you could all come here today. Now, this is, at least in the last 3 years or so, the first of these occasions where we've been able to do it face to face. So I know many of us have somewhat longed for this type of occasion once again and to come back to have this kind of interaction. And so what better occasion than the inaugural professorial lecture for Professor Tannecia Stephenson. So ladies and gentlemen, welcome. First on our agenda, we will have our Pro-Vice Chancellor. Oh my, sorry, there was one other person. And if I had forgotten this lady, I would never have been forgiven. And so I'm going to walk over. So I stand directly in front of her. And it is our director for the Office of Graduate Studies and Research, Professor Marcia Roy. So, Prof. Weber, if you would be so kind as to bring some greetings for us. I don't mind.
Good afternoon. Let me survey the room to you all. Our chair, Dr. Curtis Busby Earl, who is the Associate Dean for Graduate Studies and Research. I remember when. Can I tell you? I started there. You could be here. Professor Michael Taylor, our Dean of the Faculty of Science and Technology, Dr. Penagunda, the Head of the Department of Physics, who actually chased me down to be sure that I had a copy of the document. Dr. Campbell, Jack Campbell, who is going to be saying something at the end, I see. The Lady of Honor, Professor Tannecia Stephenson, Professor of Climate Studies. Has a nice ring to it, doesn't it? Heads of department, the Director of Graduate Studies and Research, Marcia. I see you've been able to bring out the mother of the professor and the father of the discipline. Welcome, Tony. How are you? Family members, and I mean family members of the Stephensons, but family members of the Faculty of Science and Technology, ladies and gentlemen, colleagues all, good afternoon. It is indeed my pleasure to be here and to bring greetings. Why? Because I'm home. And it's good to come home. Trust me. It's an important celebration because the opportunity for one to rise to the pinnacle of university is not achieved by all. In fact, I will say that we have had the hardest time getting the ladies of this faculty to submit themselves for professorship. I'm looking at a couple of them, and they know, and a couple that are to come, and they know that whereas some of the men will say, I'm going to try a thing. I think I have 16 papers. No, I have 26 papers. No, I have 36 papers. You know why you're laughing, right? When the ladies are ready for professorship, or when we think they're ready, they always say, no, not yet. It must be ironclad. Nobody must ask any questions. It must sail through every committee without even a and today's professor was one of those. We first suggested it when she had 30 papers, and she said no. We then tried 35 papers. She says no. We said 40 papers. Said no. I think Michael had to pull out the big stick and say, well, here is now or never. And eventually we are here where we are. But we're very pleased and proud of Professor Stephenson for the meteoric rise that she's had. The UWI is the top university in the Caribbean. We know that. And it's in the top 1.5% of universities in the world. And that's great. How did we get there? Well, the Times Higher Education ranking is one of the things that got us there. And this lady, along with many of you here, are responsible for that. 34 conference presentations, 48 publications, published abstracts in journals, not just in journals that have high impact factor, but journals that are being read and influence the decision-making process in Jamaica. Why do I know all of this? Because I had to study the CV and present it with Michael when we went to University Appointments Committee. And it's one of those that you grin ear to ear. You know, when nobody can find any fault with it? Very pleased. Our strategic plan speaks to teaching and research, as well as our academic output in terms of that research being important features. And I'm proud that Professor Stephenson has contributed, not just in teaching, not just in research, but also in administration. The university is very pleased and proud to welcome yet another professor into our midst. Today's lecture, which has an interesting title, Supporting a Climate Science Agenda from Dynamics to Impact, promises to be an enlightening discourse, bringing to the forefront some of the crucial aspects of climate that we need to consider. As we get to the end of the lecture, I am sure you will all agree that this is the manifestation of another star rising in the Caribbean, looking at a global university rooted in the Caribbean. I want to have my congratulations to Professor Stephenson. I want to say thank you very much for being who you are and how you have done what you have done. And I thank you for being another one of those lights rising from the west. Congratulations to you, to the Department of Physics and the Faculty of Science and Technology. Thank you.
Thank you very much, Prof. Weber. As always, very eloquent, always lots of very interesting comments. I am sure that there are at least a few of us here today that have many interesting things that we can tell about Prof. Stephenson. But for that particular task this afternoon, we're going to ask one of her longtime colleagues, Professor and our Dean, Michael Taylor, to tell us a bit more and to introduce our lady of the afternoon, Prof. Michael Taylor.
Principal, Professor Roy, Lady of the Hour, Professor Stephenson, all the other distinguished guests, please don't mind that I'm not calling anybody else by name. Know that you have been acknowledged. Good afternoon. So as much as it is an honor to introduce Professor Tannecia Stephenson, let me also tell you it is a difficult task. You see, even if I limited myself to just a few facts about her meteoric career, which spans joining the UA as an assistant lecturer in 2006, being promoted to lecturer in 2007, senior lecturer in 2015, and then professor in 2021, even if I just stuck to the bare minimum, we would run the risk of being here all evening. But more than that, if you know Professor Stephenson, you will know that her humility means she actively avoids being the center of attention. So there is no way then that I could get away with listing her accolades with all the appropriate superlative descriptors without being subjected to the Stephenson look of consternation or the Stephenson tone of correction, Prof. Both of which would condemn me to trying to deliver the rest of this introduction with my head fixed to that side as I try to avoid eye contact with her. To introduce Prof. Stephenson in the manner she deserves, yet maintain our friendship, is truly a difficult task. So this is what I've decided to do. This afternoon, I fall on the mercies of all of you gathered here and beg you to forgive that there are some things I am just not going to tell you as I keep this introduction simple. For example, whereas I will simply tell you that the person we will hear from this afternoon is an outstanding academic, I want it to be clear that I am not going to tell you that such a description is most appropriate given her now 50 journal articles, many in top-tier journals, 3 book chapters, 11 short monographs, 16 technical reports, and 33 conference papers and posters, which have been cited 4,511 times to date at an astounding rate of more than 700 citations per year for the last 3 years. To be very clear, I am also not telling you that she has an H index considered a measure of the relevance of your collective work of 26 and an I-10 index of 36, meaning that she has 36 publications, each cited at least 10 times. Nor am I telling you that one external assessor described her research portfolio as contemporary, appropriate, creative, and representative of state-of-the-art research in meteorology and atmospheric sciences. I'm also not telling you about the 43 million in grant funding she has acquired, the 3 MPhils and 2 PhDs she has graduated with, 4 more in the pipeline, or that she received the 2021 UE Vice Chancellor's Award for Excellence for Research Accomplishments, the 2018 Vice Chancellor's Award for International Collaboration, the Bronze Musgrave Medal from the Institute of Jamaica for Achievement in Science, and 6 Principal's Awards, 4 for Best Publication and 2 for Best Research Activity. And let me quickly say, I'm not telling you how her students describe her as captivating because of her command of physics, her confident teaching style, and her compassionate interest in them. All this resulting in high teaching evaluation scores and faculty teaching awards. You see, as much as I want to tell you all these things, I'm restraining myself for the sake of our friendship. And so I'm keeping it simple by just introducing Professor Stephenson as someone who is an outstanding academic. But very similarly, I will continue to keep it simple by saying that in addition to being an outstanding academic, the person we will hear from this afternoon is also an admired leader. Please forgive me that I will not go on to tell you that her leadership is across multiple spheres. On the Mona campus, she served 6 years as head of the Department of Physics, being the first female to do so. Her tenure was known for, and I quote, firmness and fairness, continuity and innovation, and dedication to faculty whilst promoting a sense of family. Indeed, what I'm not telling you is that the phenomenal performance of the physics department in recent years, as seen through the achievements of its staff and students, are testament to her leadership. Thankfully, she has allowed the faculty to coerce her into taking up the role of Deputy Dean, where she's rolling out a program tackling staff engagement. But I never told you that. For these things, I am not telling you this afternoon. Just as how I'm not telling you that Professor Stephenson is a co-director of the Climate Studies Group, MONA, which under her co-leadership has emerged as a center of regional excellence for Caribbean climate research. As another reviewer puts it, as a key member of the CSGM, she has helped put the region ahead of the game when it comes to climate science. And then, using CSGM as a platform, our speaker this afternoon has also emerged as an outstanding leader in the Caribbean science community, helping to coordinate the Caribbean Climate Modelers Consortium, which provides scientific leadership and direction with respect to climate science to the governments of the region. But forgive me, for as I noted before, as much as I want to tell you all these things, I will not. Because, Prof, I value our friendship. And so I am keeping it simple by just introducing you this afternoon as someone who is not just an outstanding academic, but also an admired leader. And finally, indulge me. Allow me to close my simple introduction by noting that our speaker this afternoon is, yes, an outstanding academic, yes, an admired leader, but also she's an awesome ambassador for the UWI and for Caribbean science, showing that good science can emanate from the Caribbean region. In this instance, I will risk our friendship to share the following excerpt from one of her external assessors. Professor Stephenson has steadily focused on understanding the physical processes for Caribbean climate variability and change. Her early work in detection of causes for the dry season and connections to sea surface temperatures remains a leading work in the field and an inspiration to many young scholars, including my very own students. The evolution of Dr. Stephenson to future predictions of the underlying conditions of the precipitation seasons of the Caribbean, and in particular of the dry season, have followed her earlier scholarly work with similar or even larger impact. This collection of works has shown the intellectual consistency and uniqueness of the work of Dr. Stephenson, a clear indication of a leading scholar. Furthermore, the bulk of works have added significant reputation to the UWI MONA and the Caribbean Climate Group as one of the leading regional climate research groups in the world, and certainly the leading group in the Caribbean. Ladies and gentlemen, I could not have said it better. Having taken that risk of sharing that with you, forgive me then that I, in closing, will go no further. So I will not tell you that because of her good science, our speaker this afternoon has served or continues to serve on not one, not two, but 5 global scientific committees, including for the World Climate Research Program and the World Meteorological Organization. And I will also not tell you that she coordinates the Caribbean section of the annual Global Scientific Assessment of Climate produced by the Bulletin of the American Meteorological Society. Nor will I tell you that most recently, she was a lead author for Chapter 10 of Working Group 1's contribution to the 6th assessment report of the Intergovernmental Panel on Climate Change, or the IPCC, the scientific group assembled by the United Nations to monitor and assess all global science related to climate change. That latter honor is one of the highest attainable by a scientist in the climate field. But forgive me that again, as much as I want to tell you all these things, I will, as promised, just keep it simple and introduce our speaker this afternoon as someone who is an awesome ambassador for UWI and the Caribbean science. So here then is my simple introduction. Ladies and gentlemen, please welcome to deliver her inaugural professorial lecture titled supporting a Caribbean climate science agenda from dynamics to impacts. Someone who, for a young age, balances being an outstanding academic, an admired leader, and an awesome ambassador for UWI and Caribbean science. Please help me welcome Professor Tannecia Stephenson. And if there's anything else you want to know, I will tell you afterwards. Professor Stephenson.
Our moderator, Sir Curtis, Principal, Prof. Roy, my Dean, thank you for all that you did not say this afternoon. Former heads, HODs, colleagues, all ladies and gentlemen, here and online, good afternoon. I want to thank you so much for coming out to this lecture. I really appreciate your presence with me this afternoon. We're going to speak about, and thank you again, Prof. Taylor, for what you didn't say. We're going to speak this afternoon about supporting a Caribbean climate science agenda. We're going to talk about dynamics to impacts. I'm going to assume that we're already very much aware that we depend on a number of crucial services and they're all very much climate dependent. I'm going to speak to a Caribbean climate science agenda. It's by no means the only agenda in our region. It is one agenda. And some characteristics of this agenda is that it's for the Caribbean. At the heart of the agenda is the Caribbean. And so it's framing out questions, impact questions, science questions for the Caribbean with the Caribbean as the central theme. It's being done by the Caribbean. And so important to this agenda is being able to empower regional climate scientists to do the science that is necessary for us, and yes, in partnership with international collaborators, and doing this science within the region. So pursuing activities, advocacies within the region, and exploring those solutions that are useful for our region. Mom, thank you for being here. So I'm going to take us through a number of things. We're going to speak dynamics and some of the early works and what I call the makings of a Caribbean climate scientist. I'm going to speak to observed climate change and some of the partnerships that enable this. I'm going to speak to future climate change and some of the work done by our graduate students. Speak to impacts, that is doing climate for more than climate's sake. And speaking to some of the next research frontiers and some closing remarks. So let me speak to dynamics. Our context is the year 2000. I am joining the campus. Our dean is Professor Young. Our sub-dean is Dr. Dale Weber. Yes, I found the report, sir. Our principal is PVC Hall. Very active are our former deans, Professor Magnus and Professor and Dr. Matt Morris, still at work looking at teaching laboratories. There are 169 MPhil students, and I'm one of them, and Jackie, I think you would be another. I'm coming from Alpha. That's my alma mater. I've taught for a year and returning to academia because Prof. Chen pursued me, and I thank him, and I owe him so much. And Dr. Patrick Chin is the head of our department, serving donuts every Friday. We have an active climate studies group. I came into a group with an ethos of research and partnerships. And so learning this kind of ethos is second nature. Please, this is not a 2000 picture, just in case anybody thinks I'm dating them. No, that's after 2000. And these are some of our research topics that we're pursuing. We have a Marcoon looking at ENSO and sugarcane yields, Prof. Chen and Taylor. Oh, by the way, Dr. Taylor is a new kid on the block, having just returned from Maryland and setting up his own research agenda. And he and Prof. Taylor are working on the link between early Caribbean rainfall season and ocean surface temperatures in the Pacific and the Atlantic. And Prof. Chen's student looking at the link between Caribbean rainfall and ocean surface temperature. Sir Trevor Hall is looking at hurricane predictors. And as we said earlier, Prof. Taylor, Dr. Taylor then, is setting up his research around Caribbean climate, interannual variability, and the drivers. So let's talk a little. our aim is to talk about dynamics to impacts. Let's talk about dynamics and some of the work that would have informed the PhD thesis that we submitted. So we looked at Caribbean dry season. We highlighted November to April because it was a period that was not popularly investigated. We're looking at 2-month rainfall periods. We're using a number of statistical analyses, and we're producing some maps to help us understand Caribbean climate and rainfall variability, seasonal variability. So on screen, we have applied a technique that allows us to pull out the dominant features of rainfall and sea surface temperatures that co-vary, and they explain the majority of the signal that's in the data set. Important to us, our colleagues, students, ladies and gentlemen, is where you see these intense colors, the red versus the blue, purple, they're saying that these areas co-vary inversely. That is to say, when the Pacific is warming up, we have a reduction of rainfall in the Eastern Caribbean. And when the Pacific is warming up, we have more rainfall in the Northern Caribbean. And this is for January, February. So we're using techniques that allow us to pull out the dominant signals, and these are signals that vary together. And so some of the things that emerge for us is ENSO. We've verified that it's a dominant mode of variability during the dry season, and that a warm ENSO, a warmer equatorial, eastern equatorial Pacific, is linked to drier conditions over this Eastern Caribbean region. We take a look at what's the difference in what we see in our ocean surface temperatures for high versus low rainfall years. We do that difference, and then we shade those areas where the differences are statistically significant, and it produces this map. And it leaves us with these takeaways that over the Pacific, again, equatorial Pacific, that El Nino region, as well as the Caribbean and the Atlantic, we're seeing that there's statistically significant differences in the SSTs, in the ocean surface temperatures that we see for high rainfall years versus low rainfall years. And so a drier Eastern Caribbean is normally seen during an El Nino year, and it informs on the atmospheric patterns that emerge. We're continuing to look at the question, can we predict? We're trying to understand the variability, trying to understand the drivers, and therefore, could we come out with a way to predict November to April or January, February rainfall using some of the dynamics we see emerging? That is El Nino important? Can we use it to predict the rainfall? And so if you look at this top panel, what this top panel is showing us is, if we used September, October, previous to the January, February rainfall for El Nino, and we use it as a predictor, it does a pretty decent job of capturing the variability we see for January, February over the southeastern Caribbean. If we do not use El Nino and we keep it out of the model predictors that the model can choose, we end up with some zonal gradients, that is, some differences in winds between the Pacific and the Atlantic being important, and we end up with winds over Central America being important. The fact that El Nino isn't there doesn't mean that we haven't captured the El Nino effect, because something we do the correlations afterwards, and the zonal gradient is also capturing the El Nino effect. It has some correlations of about 0.7, and it is statistically significant. So even if we don't explicitly include El Nino in the prediction model, it still emerges as an important predictor of dry season rainfall. So yes, over the Eastern Caribbean, we can produce a statistical model that can predict January, February rainfall, and we can also, if we make Jamaica the subject, and even if El Nino is not there, we can do some predictions. For Jamaica, it was important to know that, yes, we can come up with a prediction model, but because of the location of Jamaica, it's somewhere between where we transition from heavier rainfall and drier conditions. And because it's in that intermediary zone, we call it a transition zone, then El Nino wasn't useful in its predictions. So we looked at November to April rainfall, and what emerges, yes, we can predict it. What if we went to midsummer rainfall? Again, a drier period. Can we come up with models to predict? Why is it important? Because we still have rainfall in these periods, and it is still important, and we're going to speak to it for climate services to be able to produce models that can help us with these predictions. So we looked at midsummer. This is work done by Felicia White, supervised by Prof. Taylor. And something we want to highlight here, why we also chose this, is just to highlight that there are different drivers that are impacting rainfall at different parts of the season. And so when we start looking at midsummer, then one of the drivers that becomes important is the Caribbean low-level jet. It's just an intensification of trades winds just below Jamaica. And if we try to pick out the dominant signal in zonal winds, this picture emerges with this blob, for want of a better word, this area of intensification right below Jamaica that is synonymous with the low-level jet, the Caribbean low-level jet. So it is emerging as the dominant driver of winds in this period. And so we come back to the question, can we predict rainfall in this midsummer period? And something we look at, because in trying to predict it, we're trying to understand what are the drivers, what becomes important to variability in Jamaica, in our Caribbean, as we look at that period. And so on screen we're looking on the left-hand side at ocean surface temperatures again. And this time on the right side, we're looking at zonal winds, because the Caribbean low-level jet is a feature of wind. And we're trying to say, if we pulled out mathematically the dominant signals that are varying together, what would those patterns look like? And here we're seeing where whenever we have a warmer eastern Pacific, that is, we have an El Nino at work, we end up with stronger, more negative, stronger winds for the Caribbean low-level jet. And so one of the things we notice is that El Nino causes an intensification of the winds. And look at the orientation of the maxima. We think this is a synonymous. This is a typical signature of what happens to the axis of the jet when an El Nino is driving the variability. When we took out the El Nino signal and looked at what the winds look like, look that there is a change now in the axis of that wind pattern. And so something that emerges from this is whenever those differences in ocean temperatures, differences between the Pacific and the Atlantic, depending on which ocean is driving, you get a different pattern of winds. How are you doing, ladies and gentlemen? Good to see you, Mrs. Eleanor. All right, we move on from here then. Coming back to the question, can we predict this drying? And the answer is yes. El Nino is a pretty strong driver of what we see happening to the Caribbean low-level jet. And so what this plot is showing us is we could use an El Nino index to predict the variability of Caribbean low-level jet in July. And that's important because we have models that can predict an El Nino. And if we can predict the El Nino, then we could use those models to predict what would happen to our rainfall in that season. I'm hoping you're with me, ladies and gentlemen. So the sum of this part of my presentation is, as we look at Caribbean dynamics, as a group, as a region, we're advancing our understanding of some of the drivers of rainfall, in this instance, for the dry seasons, and we're showing evidence of predictability. And we think this is important, especially as our region builds on its efforts to support climate services. For those services that the midsummer and the dry periods are important, then we have done the research to show what are the drivers, what are the kind of models that can help us to predict rainfall in these periods, important for climate services. I move us then to observed climate change. And I want to speak to some of the partnerships that have caused us to have a better understanding of how Caribbean climate is already changing. One of these partnerships enabled a workshop facilitated by the Climate Studies Group MONA in 2012. We had participants, including climate scientists from the region and internationally, and we had our Caribbean National Meteorological Services present. And just for those services that are online, thank you very much for the notes and the best wishes, and thank you for joining the presentation. So that's the picture in front of our physics department. They're busy at work in the virtual lab. out of that work, they would have brought data sets together that would have helped us to quantify what are some of the changes in extreme temperature and rainfall for the Caribbean region between 1961 and 2010. Here are some of the maps that would have emerged. On the top panel, we're looking at warm days. On the left-hand side, we're looking at 1961 to 2010, but because not many stations had that length of data set, we had to consider a shorter period that would have accommodated a lot more stations. Whenever you see a red triangle, it's saying that these are areas where warm day frequencies are increasing. And when the triangles are solid, it is saying that the increases we see are statistically significant. With that in mind, we're seeing increased frequencies in warm days over the Caribbean, not a figment of our imagination. And we're seeing an increase in the frequency of warm nights. This represents warm nights. And look at the magnitudes. We're also noting that the rate of increase for warm night frequencies is greater than the rate of increase for warm days. Also emerging from this work, top panel speaks to a simple daily rainfall intensity index, just how much rainfall falling in a given day and how that changes over a period of time. And we're seeing areas, the blue here shows when we're getting wetter. These are stations showing us an increasing trend in intensity of daily rainfall. These are stations showing us increases in extreme rainfall amount, the amount of rainfall falling in an extreme event. And so we're getting to build a picture of how regional climate is changing and how the extremes are changing. We also were able to take a quick look at what could be some of the drivers. Yes, we know some of this is climate change at work, but are there other drivers we should be mindful of? It turns out that there's a longer scale ocean variability known as the Atlantic multidecadal oscillation that is also important. It varies much with the patterns we're seeing in these extreme indicators. So let me quickly just bring us up to speed. This represents warm days, warm nights, cool nights. And what the maps are showing us is there's a reasonably strong relationship between the variability we see in these temperatures and what we see over the Atlantic Ocean on longer time scales. When we do this relationship with rainfall, not as strong as we see with our temperatures, but we see some relationship there. Another partnership I will quickly speak to is a partnership that was around the Caribbean Weather Impacts Group. It brought together Caribbean scientists and scientists within the United Kingdom with a mandate of producing a number of tools that would enable us to provide climate information to the Caribbean, as well as to carry out a number of investigations, one of them being looking at the long-term trends in rainfall and temperature. And allow me to just acknowledge Claire Goodis online, who would have supervised I did a one-year UK fellowship, and she was one of the advisors of that fellowship, along with Sir Malcolm. Just to quickly point to some of the things that emerged. So the UK partners led on this work. They would have divided the Caribbean into different rainfall zones. And for each of the zones, they would have taken 2 or more data sets on rainfall and plotted out what are the long-term trends that are noted for each of these sub-regions. Because work prior showed that the rainfall across our region varies depending on the zone that you're in. And so some of the things that emerge would be a number of maps for different regions. Let me quickly take us through this one. The bars are showing us the annual rainfall minus an average rainfall from 1961 to 1990. That is to say, we're taking out the average and looking at the year-to-year variability from the average. And so we get to start seeing swings of years when we have more rainfall than normal to years when we have less rainfall than normal. You with me, ladies and gentlemen? So that's what the colors are showing. Is that a yes? Beautiful. All right, that's what the colors are showing. The blue is wetter than normal. The brown showing us years when we're drier than normal. And superimposed on this is that we have a 10-year smooth series that has been marked out. These are data that were informed by the CREW data set. It is a daily data, a monthly rainfall data set that we use to do these calculations. Our partners would have led on this. So that's what it looks for the Northern Caribbean. That's what the Eastern Caribbean looks like. That's what the Southern Caribbean looks like. That's what the Western Caribbean looks like. So when it comes to rainfall, we're not seeing any long-term trends in the mean annual rainfall, but we're seeing a number of decadal shifts, periods of years where we're either swinging from more rainfall than normal to less rainfall than normal. It was also done for temperature, and for temperature, some things jump out at us. Noticing those latter years where we're just warmer than normal and we're perpetually warmer than normal. A suggestion that we're moving into a warmer period for the Caribbean, and the warming is statistically significant everywhere. Those studies and others done for the region have been important for a number of reasons. One of them being the Intergovernmental Panel on Climate Change and the assessments that are done every 5 to 7 years. And so because of the work ongoing in the Caribbean, then maps such as these can be developed and the Caribbean can have representation. The red here is showing us areas where we have increases in hot extremes, and the two dots are to show us that there's medium confidence that the increases we see here are related to human activity. So we can get this mark for hot extremes. When we move to rainfall, though, because of a number of variables, we can't say much where rainfall is concerned. We have to speak about low agreement in the type of change. For a number of reasons, we need more rainfall data, and it's something that we have been struggling with for quite a while. There's a lot of spatial variability in the Caribbean, and so to try to define a single direction for the Caribbean is going to be problematic. And so because of that spatial variability, because of the availability of data, there's not much that we can say with respect to agricultural and ecological drought. But the studies such as these are important. Final point here is important to us is, having done the studies, we still have to keep the monitoring ongoing, because we still need to be able to speak to where are we as a region with respect to climate change. And so Prof. Taylor would have spoken about the Bulletin of the American Meteorological Society, where they do global assessments, and we do a section for the Caribbean. In 2021, it was the 5th warmest year for us, but we had to use a gridded data set. Not much station data sets going far back that could inform these analyses. We ranked about, when we look at our temperatures, since 2014, we had experienced those years since 2014 were among the 10 warmest years outside of 2018. Again, evidence that we are experiencing the climate change and we are warming. When we spoke to annual rainfall change, we were drier by 0.27 millimeters per day. But again, keeping in mind that this is a one index for the Caribbean, and we've already established that really we should be treating us as sub-regions. And so this is just an indicative value, indicative though that this was the 18th driest year since 1921. Here we're using gridded data sets to make these conclusions. So something that I think this work points to is, yes, we're getting a better understanding of the changing climate, but important to us is the continued monitoring of the climate so that we can always be ready or be in a position to give a status report on where we are with respect to climate change. Also, I think important to us is that we have climate departures to now consider. The concept that we are shifting into a new climate regime, and the coolest day in the future is warmer than the warmest day we're experiencing now. And so that continuous monitoring becomes important to verify whether the prediction that this is the year for it is indeed accurate. Last plug here for data. We wanted to do some work with statistical downscaling. Prof. Chen got me into the UK, got me into to work with Claire Goodis at the Climatic Research Institute. I'm ready to go with the data that we have gotten from our meteorological services, and Claire says, no, let us do some quality control. Yeah, man, everything all right? No, let us do some quality control. It's a good thing we did do the control. But all right, that's another matter. But what emerged from this effort is we have challenges with data. We have challenges with spatial coverage. And so a challenge we have is, even as we do the quality control, there isn't a near neighbor station that we can do comparisons with that can help us with the quality control. And so something that we piloted, something that Claire and Malcolm had always suggested is, what if we used ocean temperatures as our proxy, as the nearest neighbor? Could that work as a good proxy? And when we look at monthly variability between station data and data for gridded data sets for the ocean, they varied pretty closely. And so they became, the gridded data set became our nearest neighbor comparison for us to do the quality control we needed to do. We were able to repeat some of the extreme analysis work we did previously. These are warm days and warm nights. They're increasing. Cool days and cool nights, they're decreasing within that period, 1970 to 1992. I move us then to future climate change and some of the work that has been done with our graduate students. So one student, and this would have been Trevor Hall's work, looked at what are the projections on mean and extreme rainfall and temperature when we're using a high-resolution atmospheric general circulation model. This guy has a resolution of 20 kilometers. We wanted to see what is the picture that is giving us with respect to our changing climate. One of the things we could have done was to look at the grid, and this is work that Trevor Hall led, as well as Andrea Seeley at the Caribbean Institute for Meteorology and Hydrology in Barbados. We could have looked at different countries. In this plot, we're looking at temperatures. This one looks at rainfall. The blues are the model's version of the historical variability. The black is the gridded observation. The green are the station data sets. The red is the future projection for that location. And so we're getting this picture that the model is doing a pretty decent job of the variability. And we can also speak to what are the projections emerging. So up to 20% more rainfall at that midsummer period or for a rainfall season, and it's consistent with other models that suggest drying. And also we notice that when we look at climate extremes, up to a 10% decrease in our daily rainfall intensity, but no significant changes for these locations. So that's some of the work that informed what we see as some of the pictures of the future climate for the Caribbean. Top panel is looking at rainfall. We're looking at 3-month periods. We're looking at change in rainfall by 2075, 2099 relative to this period. This is for rainfall. This is for temperature. Last one is for winds. And the climate scientists in the room get a little happy. All right. Not really happy. Dry is never a good thing. But they've seen these pictures before, but from other models. And so we see a drier Caribbean, particularly emerging in our late rainfall season and pretty early, the February, March, April. We're seeing the hotter, yes, we expect that. And we're seeing this intensification of the winds, kind of like that Caribbean low-level jet period area that we talked about earlier. And so it's adding to that picture and our understanding of what to expect with respect to our future climate. We would have used projections from the Précis model. These are projections that Jay produced, working hard. And then Natalie would have taken them and done calculations for rainfall and temperature extremes. We would look at a period in the future, 2071 to 2099, relative to this historical period. We're looking at the Précis driven by one global climate model, just a model that has some huge grids that will have to feed in some information to a model that has smaller grids and see what it tells us about the climate. And some of the things that emerge, ladies and gentlemen, that there are just some regions where we see intensification. Those are the green areas. I'm not sure you can see the green areas, but there are other areas where we see a brown to suggest that we're getting drier. And so when it comes to rainfall, there's a variable pattern we have to deal with. But when it comes to temperature, typically, there's a strong signal, and it suggests a warmer Caribbean. A third study being done by our graduate students, this time by Dr. Roxanne Stennett-Brown. Dr. Rox, good to see you. And so, again, we're dividing the Caribbean up into different zones. to help us ensure that we capture sub-regional variability. And we're trying to understand, what do statistical models now tell us about the climate? So we have moved from 20 kilometers to 25 kilometers regional climate model. And now we're looking at data at a particular location and trying to understand what can we expect for a change in climate at these locations. And I'll just show you two maps, two graphs. And so one is we're looking at warm nights. And so remember, we're coming from dividing up the Caribbean into different areas so that we can look at what's happening with each of the different areas. I don't expect us to remember all of this, but I would encourage us that one of the takeaways has been, yes, we're seeing warmer days and nights emerging, and we're seeing an increase in consecutive dry days. The longest dry spells yearly, they are increasing. And so the takeaway point here is, ladies and gentlemen, we're increasing the picture we can paint and we can understand about what to expect about our future climate. Last one for us is with respect to tropical cyclones. Now, when you work with Prof. Taylor, you always get some interesting ideas. He's never short on ideas on what we should investigate next. And so Prof had this brilliant idea. We have been using these global models to understand hurricane variability. But what about the statistical models that we use every single year to tell us what to expect for the period? And so we started looking at, what do statistical models suggest to us about hurricane frequencies in the future? And some interesting things emerge. Some things emerge to suggest that if the model is premised on ocean temperatures and wind, then you end up with projections of these big increases in tropical cyclones. But if you end up with models that are just using winds alone, you end up with decline. So whatever informs the model, it then becomes what drives the physics of what happens in the future. And that's what emerges in these models. I will only show us one. Don't worry, ladies and gentlemen, I won't take us through all of this. But I'll only highlight one of them. This model is premised on zonal winds and some Atlantic sea surface temperatures. And when we put that, when we provide it as our initial predictors, mathematically, we use techniques that will say which of these predictors are useful, let us keep that one and throw out the others. When we do it over 1950 to 2008, both predictors are kept. But if we do it in a latter period where it's already pretty warm, only the wind is kept. And when we then look at that and look at the predictions that these models suggest as we feed in global climate model data, we see a number of things emerging. The model that has in the ocean temperatures and the wind, look at these numbers. These are changes in hurricane frequency. But if we look at the model that just has in the wind, look at the more conservative estimates we have. And so we start seeing that the dynamics become important, what drives future climate becomes important, and that adds to our understanding of what's going on with the climate. The summary here for us is, yes, we're seeing evidence of hotter and drier conditions. We're seeing the drier in the summer, but the change in the nature of the extremes requires a lot more work. The change in tropical cyclones, we need to do some more work. And so I think some of the things we emerge from this process is, yes, we're seeing some signals that are pretty strong, but a lot more work is needed, and we need to expand on the variables that we investigate so we have a more wholesome picture of future climate change. And move us then to climate impacts. And what are some of the impacts that we have been investigating? And so something that we can do as a group in partnership with others whose specializations are in those areas. With our colleagues in medicine, we have been able to look at the influence of climate variability on human leptospirosis cases. And something that emerges is heavy rainfall events and cooler conditions are pretty good for leptospirosis, and you can develop a statistical model that is able to predict the leptospirosis variability by up to 70%. We could look at temperature humidity index. Colleagues out of St. Augustine, Sir Lalou, Jane Cohen, some of you would have remembered from life sciences, Dale in physics, and other colleagues in physics would have looked at coming up with an index that is informed by weather variables. And what that index says about the heat stress being experienced by livestock and poultry. And something that I will say is our takeaway here is that at a warming of 1.5, which is a compromised position for the Caribbean, at that kind of warming, the livestock is believed, and there's suggestion that the livestock is in a continual state of heat stress for the entire year. Even at that kind of warming, where we're thinking that's conservative, it's not suitable for our biodiversity. We also looked at vulnerability and how the vulnerability that is seen within our region is differential. And typically we just think about the Caribbean and the Caribbean vulnerability, but the work Roxanne did said, no man, there's differential vulnerability in the Caribbean, looking at a simple vulnerability score, and that vulnerability changes depending on whether we include extremes in the scheme to consider vulnerability or we leave it out. And that's some of the work that has been done. We've looked at flood risk and water and rain runoffs or runoff simulations. So taking one of the tools that the group developed, looking at, so this tool allowed us to change the track that a hurricane would go on. These are hurricanes that we've already experienced in the past. So we have their historical values. If we then change the track of the hurricane, what would be the change in the wind speeds and the rainfall experienced at a location? If we change forward speed, if we change category of the storm, what would happen? And so with our Peter Mandel out of Geography and Geology leading, we were able to look at how a change in track impacted the runoff that a particular river in Jamaica experienced. We look at bushfire variability and how climate informs that. We've been able to work on teams that look at pests and how invasive species establish themselves under warmer conditions in some zones, and we've been able to look at that work. The last one I would speak to is with respect to water. And something coming out of the last Intergovernmental Panel on Climate Change report is we had a cross-chapter box that dealt with water resources. We were able to say what kind of climate change information would we need for water resources. Prof. Campbell was instrumental in this kind of work as well. And as a team, we went through, all right, for small islands, there are some issues with water we have to contend with. We're water scarce. There are other increasing demands, climate change aside. There are decreasing supplies. And we were able to build a case of this is our water context. What are the considerations that are important when we treat with climate change under these circumstances? And so when we talk about climate impacts, one of the things that jumps out at us is that we need a lot more data sets, especially with respect to sectors, and we need to make a deliberate effort to get these data sets compiled. We can't do this work without the data. And so as I move closer to concluding, ladies and gentlemen, what are some of the next research frontiers that I would like to participate in? I won't do all of these, colleagues. You know, all of us are finite. But some things that become important that we may want to consider are really characterizing heat extremes for us. We're talking about single events, but really when we experience climate change, we experience, for example, hotter and drier. What does that mean for us? Droughts and characterizing them, marine heat waves and characterizing them for the Caribbean region. We've used a few statistical methods. What if we expanded those and looked at how they contribute to the picture we paint about future climate change? What about decadal scale predictions? What about mitigation side of things? And if we had a look at what are the perceptions around some of the technologies emerging, what about urban climate change? These are some of the areas we may want to consider. As I close, colleagues, I ask your indulgence. I just want to thank God for taking me through this journey and for bringing me to this point. I have to give him glory for where I am today and what I am experiencing. I have to thank my parents and my family for the strong support that I've received from them. I could not have done it without my family. Thanks, Mommy, for making the effort to be here. Thank you for the family members watching online. For my physics family, before I reach physics family, Prof. Chen, I'm indebted. Prof. Taylor, thank you. Climate Studies Group, thank you so much. My physics family, I've included colleagues that we have worked with in the past, Dr. Walwyn, Prof. Lodenqui, Mrs. Lodenqui, Dr. Panam, all of our physics family, thank you so much. My church family, thank you so much. Church of God, Faith Assemblies, and Faith United Ministries, Miracle Temple. My UE and faculty family, Professor Kawa, who took the time to write a young researcher, Prof. Reese, my Viva moderator, and somebody who has always followed up to ensure that there was a place at UE for me and has been an encouragement. My colleagues and friends at the Meteorological Services, thanks a million for the partnerships. Dr. Goodis Online, Sir Malcolm, thank you so much for the support and the Climatic Research Unit. My undergrad students and my graduate students, I know are behind on some reviews. I'm going to try to make it up to you. But thank you so much for your understanding. My friends, my colleagues, funding agencies. And I would love every researcher and student to have the kind of support system that I've had to make it to this point. Thanks a million, colleagues.
Thank you very much, Prof. Stephenson. That was very engaging. Don't go too far. I won't keep you for too much longer, ladies and gentlemen. We have the next section, which is some special presentations. And these are some tokens to commemorate this momentous occasion this afternoon, this inaugural professorial lecture for Professor Tannecia Stephenson. One more round of applause for Prof. Stephenson. Now, before I continue, Prof, are the tokens here? Okay, wonderful. So the first would be from Professor Weber, who I'm going to ask to join us here once again. Prof. Weber. Ready for you? Prof. Weber is going to make a presentation on our behalf from the Faculty of Science and Technology. And we're just awaiting one of the head cooks and bottle washers. Yes. And ladies and gentlemen, this is Mrs. Terrian Collins Free, who I'd also like to say thank you to for her participation and involvement in arranging all of this afternoon's event. So, please. Is Mrs. Hemmings here? Yes, she still is. And Mrs. Hemmings is here on behalf of the Ministry of Economic Growth and Job Creation, and she is also here to present Prof. Stephenson with a token of gratitude. Prof. Stephenson.
Good afternoon, ladies and gentlemen, and you forgive me for not singling out anybody. You are all welcome. So distinguished ladies and gentlemen, good afternoon. It's my honor, extreme honor to be here. Tannecia is my friend. I was with her through UE. She tried to get me back, but I didn't come back, yeah. Oh, we still work closer together. But Tannecia, on behalf of the Meteorological Service of Jamaica, a division of the Ministry of Economic Growth and Job Creation, it's my esteemed pleasure to give you this small token to say thanks for the work you did representing Jamaica on the Intergovernmental Panel on Climate Change on the 6th assessment report. I am so amazed how Tannecia, I know it was hard. It's not an easy job. They don't get paid. She stuck with it. And you know why it was important? She did it continually in COVID. You would remember what COVID did, and a lot of us just shut down. No, Tannecia continued, you know, and we're really very grateful because we know how important it is for small islands to be included in this process. So Tannecia, on behalf of all of the Met Office, all the ministry, thank you very much. We really appreciate all the hard work.
Thank you very much, Mrs. Hemmings. And as we draw to a close, I'm going to invite finally Dr. Campbell to make some closing remarks on our behalf. Ladies and gentlemen, it's been a pleasure. I look forward to our next occasion. Now, as far as I can recall, I am looking forward to the next one. Let me step again in the general direction. Well, the inaugural professorial lecture, right, Dr. Campbell? Well, yes, I'm hoping to have that next inaugural professorial lecture for Dr. Donovan Campbell. Professor, my mistake, sorry, yes. And in July, at least that one is planned, we're going to have a Professor Speaks lecture that I hope you can all join us for. That will be delivered by none other than Professor Marcia Roy. So with that, ladies and gentlemen, thank you very much, Prof. Campbell.
I try to avoid setups. Now, after she gave her thank yous, I was like, do I really need to go up there? Now, ladies and gentlemen, I'll start by saying class has ended. Now, you may have seen me run out of the room at the start of the presentation, and that was for a specific reason. That specific reason was I wanted to see if she still had it. Now, if you've ever done level 1 physics, you will know when you're late for class even before you reach the class, because you'll hear those inflections going, are you hearing me? Are you with me? You will hear it, and that will imply that you've already missed something important. Now, I challenge you to wink off as she presents, because she will come and stand beside you and tap the table and ask you a question. So, ladies and gentlemen, before I get started, I have to say that. Now, all protocols are observed. Prof, welcome back. Prof, welcome back as well. Prof, nice to see you. And Prof, or ever valiant leader, welcome. And Prof Emeritus, I can't say anything more. All right? Now, I stand before you today in awe and with an overwhelming sense of gratitude. Right? This was a momentous occasion. You'd have heard it. She was the first head of the physics department. Female, that's what I meant. First head. All right? Now, there are a lot of firsts that are under her name. But I'm going to skip all of that because I'm here to give you a brief closing remarks. Now, Professor Stephenson, what you did today might have just made climate seem so sexy to everyone here. Climate has impacts where energy is concerned, health, you name it, the built environment. You can find a use and you can find utility within climate. So after that talk, I'm expecting to see more of you in physics. All right? Beyond the wealth of knowledge she shared, you must have realized that there is passion inherent in what she's talking about. Now, if you didn't get it, when she raises her voice, it's not important. When she drops her tone down and you can hear her very, very clearly, it means that she's just made an important point for you to follow. So she's making sure, if you're drifting off with a high tone, you must come back to the important thing with a low tone. All right? In the few moments we've spent here, right, you've reminded us that education is not merely about acquiring the facts and the figures, right? It is a transformative experience that ignites the flames of curiosity. And you can see that at the end of it, I'm not sure how she's going to do all of that, but there is still a burning passion. There's still a burning curiosity, right? On behalf of everyone present today, I extend my deepest gratitude to Prof. Stephenson, right? Your lecture has left an indelible imprint in all our hearts. As you've heard, today was awesome and awe-inspiring. So with that, I thank you.
Thank you very much, Dr. Campbell. And ladies and gentlemen, that brings us to the end of this formal part of this afternoon's event. Don't leave. Thanks to the climate group. There are some, and the Department of Physics, there are some refreshments just outside of this lecture theater. So I'll invite you all to join us there. And I look forward to seeing you all again, as I said, relatively soon, and enjoy the rest of the afternoon. Ladies and gentlemen, thanks again.